All right, and moving on with our unit on table of values and recognizing functions. All right, and some properties of functions from those tables. Today, we're going to look at quadratic functions and table of values and see how we can recognize some of the similarities and differences between quadratic functions, and our absolute value functions and linear functions. All right, so you can see that the three standards or topics that we're going to work on today. 1.3, I can identify quadratic functions from a table. I can identify rates of change for quadratic, and I can extend that table in much the same way we've done with linear and absolute values. So once again, the questions aren't changing. All right, so we're asking the same questions. What type of function? What's the rate of change? What's the next value? Or what's this particular value? So that's the good thing. So what you have to focus on then, because the questions aren't changing, is those defining characteristics of our functions. All right, so let's look at the table and the opener together today. I know I normally have you pause the video, all right, and do the opener on your own, but this one's a little bit different. So I want to go through it with you, and we're going to probably pause and do some different things, all right, and so we can see some of the patterns that are there. So here's what I want you to do, right? So the first thing is, all right, I'm going to look at my X's here, or I should read the opener here. The table value represents a penny being dropped from the top of a building that is 1,000 feet high. And we want to determine when the penny hits the ground. All right, so notice we have our time in seconds here, and what you can see from our table is that the time in seconds is increasing by 1, right? So we go from 0 to 10 seconds. So that's pretty good. Now here's what I want you to do. And I want you to pause the video, and I want you to find our change in y's right here, and then flip the video back on, and then let's talk about what you see, or what hopefully you will start to see within that pattern. So go ahead and pause that video. I'm going to do the same, and we'll flip it back on and see how our values match. Okay, so I did the same thing that you guys did. So I paused the video, and I found my rates of change for y. All right, so hopefully the 5 values I have here are the same ones that you have in your table. Now, here's the first thing that should be obvious. When I look at my rates of change, negative 16 to 1, negative 48 to 1, negative 80 to 1, negative 112 to 1, negative 144 to 1. It's definitely not constant, right? We definitely do not have the same unit rate of change, right? Because now it's negative 16 to 1, negative 48 to 1, right? So here's what you should know right away. It can't be linear and it can't be absolute value. We do not have a constant rate of change. All right, so one, those are off the table. Now the question is, what type of pattern is occurring within this rate of change? And this is why I wanted to go through this with you, because for a lot of students, this isn't obvious the first time we see this. Now, after you see it, then hopefully you start making those connections. So here's the pattern. These numbers are not constant, but how they change are. And that's the big idea with a quadratic, all right? So when I look at this, notice when I go from negative 16 to negative 48, I went down 32. When I go from negative 48 to negative 60, I go down 32. When I go from negative 80 to negative 112, I go down 32. When I go from negative 112 to negative 144, I go down 32. And that is the pattern that we want to see in a quadratic, all right? Or that tells me that it's a quadratic, is that if the rate of change is changing by a constant, all right? So how do I get my next rate of change? Is I have to subtract 32 again. So notice I need to subtract 32 again. So negative 144 minus 32 says now I should go down negative 176. So 600 minus 176, now that penny's at 424 feet after 6 seconds. Well, to get my next rate of change, I have to subtract 32 again. So negative 176 minus 32 is negative 208. So 424 minus 208, that means after 7 seconds it's at 216 feet. To get my next rate of change, I subtract 32 again, and that's negative 240. And notice what happens here. So 216 minus 240 is negative 24. So if that penny went through the ground, right, at negative 8, or excuse me, at 8 seconds, it would be negative 24 feet deep. So here's what I know, right? At somewhere between 7 and 8 seconds, that penny hit the ground, right? Because hitting the ground means the height would be equal to 0. All right, so between 216 and negative 204, so probably closer to 8 seconds, all right, than 7 seconds. So we would say, oh, approximately, maybe 7.6 seconds, 7.8 seconds. We would just estimate it, but we know it happened between 7 and 8, and probably closer to 8 than 7. Now, I kind of gave this away. What type of function do we think this is? And this is a quadratic. Your y right now might still be a question. All right, and you may not have understood that. All right, and that's okay. But the y is really this idea right here. Okay, it has to do with this rate of change. If your rate of change changes by the same amount. Okay, and so what do I mean by that, right? So notice, all right, if I go 1, 3, 5, 7, 9. So this is definitely not constant. But notice it's going up by 2 every time. Okay, so notice it's changing by the same amount, right? So maybe I go 7, 11, 15, right? 19, 23, right? So definitely not constant because it's changing, all right? But then notice it's changing by the same amount. It doesn't have to be going up either. It could be going down, right? So maybe I have 21, 16, 11, 6, 1, -4, right? So definitely not the same value every time, but it's changing the same way, right? And that's what tells me it's a quadratic, all right? So that's really the big idea that we want you to see, all right? So if your rate of change is not constant, right? So I do not have a constant rate of change. What you want to look at is and say, ask yourself, is the rate of change changing by the same amount, all right, every time? So now let's go down and take a few notes on characteristics of a quadratic function. All right, so the first thing, and once again, we don't see it in this table, but one of the first things that we're going to look for, and we mentioned this before, is that we're going to look for a turning point, all right, or a vertex. So a quadratic, all right, is a U, and we looked at that in that opening activity at the very beginning of this unit, right? It looks like a U, and I'm going to go down and mark that right here, right? So we know one of the characteristics is that it looks like a U, correct? All right, so it's either going to open up or it's going to open down. All right, and so that's one of the characteristics that it has in common with absolute values. They both have turning points. All right, so it's going to go down and then up and then up and then down. And what's different is how it goes up and then down. So 2, all right, the rate of change is changing by a constant value. All right, and so the verbiage that we're going to use, the terminology that we're going to use, all right, is we're going to describe what we see here. So like, for example, we would say that this rate of change is increasing by 2. This rate of change is increasing by 4. This rate of change is decreasing by 5. So once we find this number here, and we call that number the second difference, if you want a word for it, all right, or a way to talk about that. So we just say exactly what the second difference is doing. It's increasing by 2, increasing by 4, decreasing by 5. All right, now, because we have a U graph, all right, symmetry is also another major characteristic of our quadratic, right? So we should get matching values around that vertex, whether it opens up or whether it opens down. All right, so let's take a look at some examples together. So let's flip, all right, to the back page here, all right, the back of your page, back of your notes here, and look like problem 1. All right, so once again, asking the same question. What's the rate of change? What's the function? Can I fill in missing values? All right, now once again, we're kind of building up here. So notice now we have 3 functions we have to kind of be aware of, right? It could be linear, could be absolute value, could be quadratic. All right, now once again, one of the things that we want to do is the first thing we want to do is look at our table and see if we have a turning point, because once again, that cuts it down to 2 choices. If I have a turning point, has to be absolute value, has to be quadratic. If I don't see a turning point, then I'm going to do a little bit more work, and hopefully we'll see an example either in this video or in class of showing that progression. So let's look at number 1 here. And so the first thing I'm going to do is I'm just going to scan my table, and I'm going to see if I see a turning point. I'm going to look for symmetry. I'm going to look, does it go down and then up then down? And what I see here is I see a turning point. All right, I can see that it goes 8, 5, 4, and then 5, 8, 13. So right now I see I have a turning point at -1, 4. So because I have a turning point, now I'm down to 2 choices. Either it's absolute value or it's quadratic. And what's going to tell me the difference is the rate of change. If I get a constant rate of change down and up or up and then down, it's absolute value. If I don't get that value, if I get something that changes at a constant, or excuse me, if the rate of change changes by a constant value, then it's quadratic. All right, so let's jump into those rates of change and see what we see. So I'm going to look down my X column here. So when I look down my X column, I can see that everything is increasing by 1. So I'm just going to do that real quick. All right. And so now I'm going to jump into my Y's, and I'm going to see how my Y's are changing. So when I go from 8 to 5, I go down 3. So my first rate of change is negative 3 to 1. Now when I look at my second change in Y, when I go from 5 to 4, I go down 1. So my second rate of change is negative 1 to 1. Those are not the same. They do not mean the same thing. So I do not have a constant rate of change. So it cannot be absolute value. All right? Cannot be absolute value. So we're leaning to quadratic. Now let's finish our pattern so then we can see, all right, how we describe that rate of change. And so notice now I change direction. I go from 4 to 5, I go up 1. When I go from 5 to 8, I go up 3. When I go from 8 to 13, I go up 5. 13 to 20, I go up 7. And 20 to 29, I go up 9. All right. So notice you can hopefully you see that this is definitely not a constant rate of change, right? Negative 3 to 1, negative 1 to 1, 1 to 1, 3 to 1, 5 to 1, 7 to 1, 9 to 1. So now the question is, right, do you see a pattern in how these numbers are changing? So when I go from negative 3 to negative 1, notice I go up 2. When I go from negative 1 to positive 1, I go up 2. 1 to 3, up 2. 3 to 5, up 2. 5 to 7, up 2. 7 to 9, up 2. So here's what I know. It has a turning point and a non-constant rate of change, all right? And we see this pattern here, so this tells me that it is in fact a quadratic function. How do I describe that rate of change? My rate of change is increasing by 2. So I would say my rate of change is increasing by 2. All right, so increasing by 2. Let's do one more together. All right, so let's look at number 2 here. So once again, I want you to scan it, pause the video, scan this table and see if you can find a turning point and circle it or highlight it. Okay, hopefully you did that. Now, when I look at this, once again, I see 2, 6 as my turning point. I can see symmetry around that. All right, so I can see matching values. I can see that it's going to go up to 6 and it starts going back down, right? So you have a couple of key indicators to help you find that turning point. All right, so now once again, because we have a turning point, it's either absolute value or quadratic. So now we want to jump into those rates of change to see which one it is. All right, so now I'm going to look at my x's here. All right, and what I see with all my x's is that they are all increasing by 1. So let's just go ahead and do that real quick. So all of my x's are going up by 1. So now let's look at, all right, our rates of change. So when I go from negative 44 to negative 26, I go up 18. All right, so remember when I go from negative 44 to negative 26, I'm going up 18. So think about like floors in an elevator, right? The negative 44 floor would be way down low, right? So if I get to the negative 26 floor, the negative 12 floor, negative 2 floor, and then the 4th floor, right? So I'd be going up that elevator. All right, so when I go from negative 26 to negative 2, I go up 14. When I go from negative 12 to negative 2, I go up 10. So let's look at these first 3 rates of change, right? 18 to 1, 14 to 1, 10 to 1, not constant, right? So when I look at those 3 rates of change, right, those are not the same. They don't mean the same thing. So it can't be absolute value. So now what I'm hoping is that we're going to continue this pattern and we'll see if we can find, all right, a similar pattern to what we saw here to describe it and can verify that it is in fact quadratic. So when I go from negative 2 to 4, I go up 6. When I go from 4 to 6, I go up 2. And now that elevator starts going the other way, right? Because now I'm at the 6th floor, but then I'm back down to the 4th floor. I'm going to that subterranean level. I'm down 6, right? And then negative 12 to, or negative 2 to negative 12, I go down 10. All right, so definitely not, absolute value because we do not have a constant rate of change. So now the question is, do you see a pattern in this rate of change? How are these numbers changing? All right, so pause the video, see if you can find it, and then flip it back on to see if it matches what we say. All right, so when I look at this, when I go from 18 to 14, I go down 4. 14 to 10, I go down 4. 10 to 6, I go down 4. 6 to 2, down 4. 2 to negative 2, down 4. And so my pattern is these numbers are decreasing by 4. My rate of change is decreasing by 4. So that's how we would describe it. And once again, turning point, my rate of change changes by a constant value, and that means that is a quadratic function. All right, so there's your intro to quadratic functions. We'll continue this conversation in class. If there's any questions you have, make sure you're highlighting problems, writing those questions down. All right, be ready to present those when we see you in class next time.